And welcome to my talk. I'm going to talk to you about building this, a mobile flight simulator owned by British Airways and run by a group of pilots within British Airways. I talk to you about how and why this exists and what we do with it. Get my slides to click over. There you go. A bit about me first. My name is Clifford Agius, and I'm a senior first officer, and I fly the 787 around the world for British Airways. I can say it now because this talk's been approved by the press office. Normally, I'm not allowed to say it in my talks. When I'm not flying planes around the world, I'm a freelance .NET Xamarin IoT developer. So you often find me in a coffee shop somewhere in the world, thrashing at my keyboard and building something. Passions, coding, building, making things, and supporting others in doing that as well. So code camps and things like that. That's my office up in the top right there. So I'm a senior first officer, sitting in the right-hand seat of the aircraft. Captain sits on the left. If you're in a helicopter, it's back to front. That's just because helicopters are weird. But in a fixed-wing aircraft, that's what they are. I'm often asked, there's two things in that image that you can see. You can see up here the head-up displays, or HUD, as we have on the 787, which mimics this main PFD, primary flight display, onto the HUD for our flight controls or flight instrumentation. And then the cutout in the seat, I'm always asked what that is. That is because some people have short legs, so they have to sit quite far forward, and it means the control column can come all the way back between your legs to make sure you can pull up if you have to do a pull-up go-around, which is when you're approaching a mountain and you really don't want to hit the mountain, do we? So you need to pull the control column all the way back to the stops. That's why you often see female pilots be wearing trousers rather than skirts and dresses and things. It's so that they can pull that control column all the way back. That's enough about that. Let's talk about the simulator. This is what the simulator looked like when I joined the team back in around 2009, 2010. It's old, it's tired. It turned 30 last year, so that explains how old the trailer is. Inside, as you can see in the left-hand image here, you can see the old FMPT2 trainer, which is basically a procedures trainer, which is used for training pilots fly light aircraft. So it's really small, like a light aircraft cockpit. There's a big step, and just see the radiator here. There's a big step of about just under a foot to get up onto that, and you had to climb over the seat to get into the seat to fly the plane. It was very loosely, and I say very loosely, based on a 737. So the flight model in Microsoft Flight Sim at the time was a 737, but as you can see, the controls that were there were very much not a 737. On the outside, you can see it's quite old and tired. The paintwork was painted to look like a British Airways aircraft, so blue bottom, which hides all the oil and stuff at the bottom of all aircraft, no matter where they are in the world. But yeah, the trailer was a bit old and tired. And in the back, you can see we had a couple of beaten up Dell Tower PCs, some what were then pretty decent graphics cards. Feeding out, and then in some splitters that then fed out to the different monitors. And there were two monitors in front of the different people. She had the pilot, the British Airways pilot, and there was always a line pilot sat on the right hand side. Then whoever's having a go sat on the left, and hopefully it worked and carried on working for the event. Now we took the sim to events all around the country, across in Europe as well. And we took to air shows, corporate events, STEM events at school. So we taught them about aviation, science and maths behind aviation. Then the kids, whoever did the best at the lessons and exercises, the following day got to come out and fly, and their friends shouted up, down, left, right from the back, which is always good fun. And it's a bit of giving back to school. Air shows, we take it along and we charge money. And the idea behind that is we raise money for charity, which I'll come on to later. And we also take it to corporate events where we charge a corporate customer a bunch of money, and that all goes to charity as well. BA take nothing out of this. They put a little bit of funding in, very little each year, just keep it going, and all the pilots are volunteers. So all the money that the sim takes in goes to charity as well, which is fantastic. We've moved on though. I talked about the charity support. One of the main charity support is Dreamflight. Now, Dreamflight is a charity set up by British Airways crew some years ago. And they take disabled, disadvantaged, and terminally ill children, and they take them on a trip of a lifetime. So these children have really gone through the ringer. They've really struggled. You know, we've got children suffering from brain tumours, you know, all sorts of different ailments and diseases and illnesses, or they've just had a really tough time in life. So we take them, we stick them onto what We did. The last one was obviously in 2019. We did stick them onto a 747 aircraft, so we'd take about 200 kids, and then along with them we'd take cabin crew and flight crew and ground staff that would act as helpers and mentors, and we'd take along a bunch of doctors and nurses, depending on the different ailments that were in the group that go in that year. So they had all the medical team with them in case they needed any assistance. We had all the staff were all trained on helping them. So if they were wheelchair bound, as you can see at the front, we'd have staff that were specially trained in to help them doing the simple things like going to the toilet. And the thing was, these children were never allowed to take a parent, a grown up, a guardian, a brother or sister. It was their time away from the family. It was 2 weeks in Florida. And Disney supported it as well. You can see all the Disney characters. So it's a fantastic break for the kids, but it's also a break for the parents and the siblings, because it meant that they got 2 weeks of having to care for the child. Now, if you've got a child with an ailment, you love them to bits, but sometimes you do need that break. And this was a break for the family as well, for the children. It's a wonderful charity, Dream Flight. You can go on the internet and you can, they've got a Just Giving page if you feel like you want to spend some of your money and share it with them. We've not been out giving any this year because obviously the sim's been parked up all year, so it's made no money for them this year, sadly. Hopefully 2020 we didn't make any money. Hopefully 2021 we'll be able to get out there, but it's not looking too good at the moment with the pandemic. But let's move on. Let's look at the sim again. So we go back to how it was. I talked about the fact that they go back a slate. You can see we've got a few children now that are in wheelchairs, others that are just less mobile, and they can't lift their leg up, like cerebral palsy and the likes of those medical conditions. You can see here we've got a nice big step there and another big step there, and then we've got the other big step up there. So there's some quite big steps that have to get up to. So wheelchair bound people could never have a go. Those that were less mobile, they could potentially have a go. I've got a heater burning my feet down there for some reason. And then when they get in, they've got to clamber over the seat as well. So for the less mobile children, it wasn't great. Air shows and things with fully able people, it was fantastic they could get in. You also got this big foam lump at the top as well. So you can't really lift them into position because you can't get an adult or grown person next to them. So we had an occasion where a parent would try and lift their child into the seat, and it just wasn't going to work because they had to be bent over and stooped to get in there as well. So we had at one event a young girl come along, and she really wanted to have a go. I was there, I was leading the team that day, and she come along and said, "Dad, I want to go, I want to go, I want to go." And her helper was there as well. We had some other team members there as well. And the dad tried to lift her in. It wasn't going to work, so put back in a wheelchair, and she went off crying. And that for me was, it hurt. It was like, she really wanted to have a go. She really wanted to, fly a plane. Aviation, she's fascinated by. And it was like, we got to fix this. We can't carry on like this. At the time, we just started looking at refurbishing the sim. So it was like, well, let's do something about that. Let's fix this. Let's make it better. British Airways had just ordered its first 787s. I'd just been told I was going through movement of 787 fleets when we got them, which was about a year and a half away. So that's the flight deck of a 787. The picture I took. So it's like, oh, that's good. But the first thing that sprung to mind was the fact that 787 has control columns, which come back, like I say, into the gap in the seat. We've got a wheelchair that potentially couldn't happen, but okay, maybe they could pull it back just enough or move the seat back, their chair back a bit. We need wheelchair access as well. So I initially thought, well, although I'm going to a Boeing with a flight control, I at the time was a short haul Airbus flying A320s around the world. So why not go to the aircraft we do have in the company, which is the Airbus A380s. It's big. It was all over the press because we'd just got them. It's fantastic. As you can see, Airbuses have side sticks. So you have captain and first officer side sticks there. So it's just a joystick. So connecting that to computers, it's simple. We can do that. We just plug the thing in. And you can even buy these joystick covers on the different flight sim. Well, that's flashing now. On the different flight sim part suppliers. So we could have bought those, plugged them in, and good to go. Went along to a meeting with our team of managers that work, in Waterside, our head office, and talked to them. And sat down at the table and said, I want to do it on the 380. At the time, the 78 was coming, and they was like, no. And I said, well, because the joysticks, and the managers were like, no, the planes don't have joysticks. They have control cones. My light's just blown. Okay. I've probably gone dark because my light that's up there is just literally blown. Oh well. Anyway, what was I saying? Yes, so they were like, planes don't have joysticks, they have control columns. A big thing. It's like, no. The biggest fleet in the company, over 200 aircraft, is the Airbus A320 family, and they all have joysticks. No, they don't, Cliff. So we brought up a picture on the internet, and they thought I was lying. Eventually, we took a couple of them to Simulator Hall, where we've got our flight sims that we train on every 6 months, and took them for going the sim to prove to them that planes do fly with joysticks. But it just goes to show that management of companies often don't know what the hell is going on down on the shop floor, which made me giggle. But the decision was made was going to go with a 787 because they thought it looked good for. By the time we built it, we said we'd take a year to build it. It looked good for the press and everything else. So we went back to our trailer and we started hatching a plan of how we're going to build this. We roped in our SEP engineering team, which is the team look after SEP Hall, which is Security and Emergency Procedures Hall, which is where all the cabin crew and pilots train every year on things like opening the door, evacuating the cabin, putting out a fire, doing emergency drills, like if someone has a heart attack, how do you do CPR, and use the heart start kit, emergency berth on board, all these sorts of things that our cabin crew are trained, and pilots as well, is what gets trained at our special training centre at London Heathrow. So we went and got those guys because they are experts at building demonstration systems and sims. We got some of our sim engineers as well, and we started taking the trailer apart. So this is me working with our engineering apprentices at the time, and we stripped out the old trailer and completely emptied it. Then we started looking to rebuild it. So we went down to the only 787 sim, and the only 787 in the UK at the time was at Altion, which is Boeing's facility down at Gatwick. We went down there and took some pictures and some measurements. We spent a good few hours in their simulator there, which is still being built. It was that new. And Boeing was a fantastic help. Once we'd done that, we come back and started attaching together drawings and designs and getting some sheet metal folded to put the screens in. As you can see, we bought some screens off of eBay, some 15-inch NEC LCD monitors, just normal PC monitors, but small ones that fitted in there, exactly the same size as on the aircraft. And then you can see Dennis here. This here is the throttle quadrant. We'd just retired a few 747s at the time, and that was a throttle quadrant out of a 747, and we wanted that to control the throttle so it was realistic. You can see here the other two parts, because obviously a 787 has only got 2 engines, the 74 had 4. So we had great pleasure with the help of Dennis taking an angle grinder and cutting that in half, and yeah, it was great fun. Lots of smoke and sparks. But we cut that up, and you can see Dennis there is now putting it all back together and fitting it up so it'll fit inside the sim. So then we built the whole sim, and it took us about 6 months, and this is what it looked like. What it looks like now. We took it across to our paint bay. We had one at the time, and we took it across there and handed it across to our paint team, and they painted it up. We got some interns in our sales marketing team to come up with designs to make the sim look like, and make sure it was on brand and on message with new brands. So instead of having the blue and whites, we put together some nice graphics. So yeah, it's pretty impressive. The only bit that I can spot on here, and those that aviation geeks will spot, is the fact that it's 15 minutes to landing and it's 210 tons. That's above the max landing weight of a 787. But yeah, they were interns, and yeah, they hadn't quite learned. So even up in the office, they hadn't quite thought to ask us the characteristics of the aircraft. They just got it off of Google and went with that. But you can see here now we've got 2 seats. So we've got the captain's and first officer's seats, and this seat here comes all the way back 2 meters from the controls. So it gives a 1.5 meter gap, so that a wheelchair can come up around and wheel all the way up to the flight controls. There's no step inside the simulator anymore. So the flight controls, the base of the flight controls actually go under the floor of the trailer. And we basically put a big trough under the floor of the trailer. Which was great fun when I went to procurement and said that I need a purchasing order for this trough to be made. And they literally called me up on my phone and said, why are we getting a pig's trough being made? And it literally was The manufacturer made out of stainless steel. It was a trough that pigs use for drinking from. And they were all confused, but we got the trough made and fitted it in the floor of the sim, and all the controls now sit in the base of the simulator, which means we have a completely flat floor, which means we can have a ramp. So you see here, the OSMP engineering team built this out of wood. They did build us one out of aluminium later. We haven't tried it yet because of COVID and the shutdown last year. But now we can roll a wheelchair. You can see the young lad in the bottom left there has rolled his wheelchair all the way up into the simulator. Through the doors, we've made slightly wider as well, all the way to flight control. He's having a go at flying the sim. We even branded the ramp. 27 left is the runway at London Heathrow. There's 2 runways, 27 left, 27 right. Obviously, the opposite direction is 09 left, 09 right. So you can see here, there's a handrail as well to stop people falling out of the sim. So they come all the way around and up to the control column. And then just while we're here, we can see up here is the instructor station, which is where they use to control the simulator. And then we've put wraparound visuals. So rather than just having 2 flat panel monitors, we've got wraparound visuals. And they are 3 classroom short to throw projectors made by NEC. Amazing devices. They're 6 inches away from the projected screen, and they project quite a big image up onto the screen as well. They were gifted to us by NEC, so I just want to call it out for them as well. So that was pretty good as well. So you can see here, this is at an event. This is at the Dreamflight event. So this was their event at the Hilton Hotel at London Heathrow. So the children all come there the day before. They get experience the flight. They get to, there's jugglers and musicians and magicians and all sorts, and they get to say goodbye to families. There's a meal put on that evening. And the following day, they jump on their 747 and fly to Disney for a couple of weeks. So I went back the following year and got to experience this when we built it, and see these children come along in their wheelchairs and having a go. I'm not ashamed to say it did bring a tear to my eye. It's pretty impressive. The only thing you could probably spot is the fact that the one thing we didn't think of is the fact that when you get a short guy or girl come in, they couldn't see out the window. But believe it or not, he flew the approach absolutely brilliantly, because we taught him what to look for on the controls, on the flight controls, on the flight instruments here, and Xbox and PlayStation Nation. He flew it on RAWs. It was an impressive thing to see. It put us pilots to shame. And then they get a certificate, which is signed by the pilot who's in there with them to take away as a memento as well. But now what we've done is we've got a little wooden ramp. So if they are quite short, the wheelchair can go up and sit in the wooden ramp. They apply their little park brake on their wheelchair, and then they can see out the window as well. So we've learned and moved on. And that's always the thing. With all things, you always learn and move on, don't you? You always adapt and move on. But let's talk about how we built this simulator. We have inside the simulator 3 PCs. Over the last year, we've fitted a few more to have spares and to break out the external view. And we're going from just 1 external view PC, driving 3 projectors, to 3 PCs driving a projector each, and then using a hardware frame lock from a company called Matrox. We're using their new graphics cards that have a frame locking system, so you can lock the frames of the 3 projectors, which is it's quite impressive bit of kit actually, and not cheap, but they've given us a loan of it. But you can see here the controls, all the controls come into the instruments PC. Instruments PC drives all the flight instruments, which are the displays you can see. So the 5 display screens you can see there. And then you have an instructor's PC with a touch screen, which was the one that you see before, and then an external view, which is driving the graphics and the projector's engine. So that's all connected together, and we use some software called WiredView, etc., to connect all that together. And then we have a 4G connection, which allows us to remote in with remote desktop into the system. So when it's at an event, I can't be there as the person that looks after it. There's another company called Future Software, based in West London, that support it when I'm in the air and I can't be nearby. They've helped build this over and maintain it over the last few years. So if I'm in the air flying, the team will call up the team there, and they can remote in and try and help fix it. You've got to remember that when it's an event, it's all real life airline pilots. So they can fly a plane, but they may not have the technical knowledge to fix a PC. Or how to do a full reboot or set up the system again. So that's the backup, is the fact that they can remote in if needed and do it for them. Underneath the floor, you remember I talked about that pig trough That is controls under the floor. So BFF simulation, we found those and we got them to build us some kit. So you can see we have some bike chains that go up. So as you do roll, so left and right, it moves that bike chain and it comes via this motor and encoder, and then we use the motor as a force feedback. So if you roll on too much bank, it will provide some force feedback. And then you can see in pitch as you push left and right, this plate moves in and out the screen as you're looking at there, rotating this bar here, moving this arm, and then via a reduction gearbox, which we're driving back the other way because we want that only moves about 6 inches, but we need a good 20 or 30 rotations so we can sense the movement. So we use a reduction gearbox going back the other way, and then via the motor and encoder, we can sense that value coming into to flight sim. The yellow cables, I've been asked before, are actual real aircraft component cables. So they come down, they're braided cables that come down with some specialist cap cable inside, and that comes down from all the switches that are on the control yokes. That'll be the autopilot disconnect, the pickle switch or push to talk switch, and then the trim switches as well. You'll have a couple of trim switches up there as well that you can control. So that's the controls. Inside, I've used this picture so you can see how it's been made and built. So you can see the frame that's welded frame, and then you got the screen in the middle. These here now, I've had a new picture. These are actually, rather than being stickers, they're actually now buttons that have been 3D printed and stuck on. And then we're going to make another one with actual real buttons that actually work, as opposed to just a 3D printed lump that's there. You can see the throttle quadrant in the center, which has got the throttles, the reverse thrust levers, flaps and speed brake and engine control switches. That is now, we moved on from the 7471 broke after a few years, because it was where we cut it apart and trim bits off it, we basically weakened it too much and it started to foul. And obviously we couldn't just go and get another one because they're expensive bits of kit. So what we did was we built this. We had the SCP engineers build this, and we lots of 3D printed components on that as well. On the right hand side, we have a Leo Bodnar board. If you ever need to get switches into your PC, you want to do a little bit of IoT. You just want I want to build that button with a big light on it or something. Leo Bodnar make these boards. They're fantastic. They basically appear as a joystick or a keyboard. So as a joystick to your system, but this one has got 32 inputs, so you can use it like a keyboard, but it appears as joystick buttons, which obviously you can link into with your chosen bit of software in there, and they're dirt cheap. They're like 20-30 pound each. So they're really good. They're designed and used in the simulation and world. So lots of Formula One teams use them in their simulators. And that's where this company was built from. The team that originally worked in building simulators for British touring car and Formula One teams. Great boards. So we've got a couple of those in there, but also we have some Arduino boards in there as well. It's been IoT talk. The ones that we've used are ones that I use quite a lot with clients. These Tinsy boards, they're 32-bit. And they're quite fast. We use mostly the 3.6 Tinsy boards, so 180 megahertz. As you can see there in the center board, and we use that because we could use just direct inputs, but then it just appears as a joystick input. In flight sim, you can set up the switches to trigger things like gear and stuff. But what we wanted to do was we wanted to control not just like for the speed brake, we wanted to control not just the fact that it's there, but on the speed brake in the actual aircraft, you've got a analog movement. But also you then lift it up into a closed gate, and that is then a switch. So you've got an analog movement and a switch, which obviously you can't really do with just a plain joystick. So we've wired up to that. So then what we do is we have the code that looks at the analog input and the switch, and then decides to tell flight sim whether it's in the stowed closed position or if it's in the intermediate position or fully open. So what we can do is we can pre-process on the code what that input is doing, and then send the correct input to either as a joystick input or a keyboard input into the PC. So as far as the PC is concerned, it's got a joystick and a keyboard plugged in when this is plugged in on USB. But then we can control the values that go in, and obviously put hard limits at the top and bottom. So the sensor fouls, we can put hard limits. And also what we've started doing over the last year, is putting in spare switches at the side of the instructor. So if the main instrument breaks at an event, they've got backups on the right hand side as well. So we're going to the software. So we've got Prepared 3D is what we use inside the simulator and have been for many years now, and that is made by Lockheed Martin. It's what they use in their professional sims. We've got Orbix, which is the visuals outside world, and then we use Quality Wings for the 787 model. Fantastic. It's, as a 787 pilot, it's 98% the way there to being absolutely spot on perfect for the aircraft. There's a couple of bits where they're missing. I actually, when they're building it, I see some early beta versions, and they're fed back as a pilot. It's like, that isn't quite right, and that's the wrong font. Even the font on the screens is perfect. Then we use Wide View, which does the sharing of the views between different PCs. And then we use FSUIPC from Pete Dawson. It's a wonderful tool to allow you to control the flight sim world. So FSUIPC, as I say, is a great tool. Flight sim, universal inter-process control. If you've not used IPC control, I'm going to take you through it, don't worry. So what happens is the IPC has a shared memory block. So Prepared 3D is the first process. The 787 iOS Instructor's operating station, it was, the flight sim world had it way before Apple ever thought up of iOS. So that's why it's capitalized for us, and I dare say not for them. And then there's this shared memory location in the middle. And what FSUIPC does is every frame, it jumps into process one, which is Prepared 3D on this slide, and updates the values, or grabs world values out and updates this shared memory. And then your process two, which is your software, you jump in and look at that shared memory or poke memory locations for new data, and it'll update it the next frame updates, which then means that you can read and write data into Microsoft Flight Sim or Prepared 3D. But it also then means that you can switch out Prepared 3D. And what we did last year between the lockdowns, the many lockdowns we've had here in the UK, was we switched out as a trial Microsoft Flight Sim when it was released, which then means we can get things like this. This is a 787, hopefully the sound's coming through. This is the 787 model in Microsoft Flight Sim, which you can see is pretty good. It's about 60% the way down. So it's not ideal, not 100%, but it's getting there. But you can see the outside world is much better as well. So we could do that just by switching the process that's process one. And FSUIPC has not changed. It's looking at the same memory. They've mapped the memory locations. So now that means that our 787 iOS station looks like this now. You can see Future Software. High Flight is another charity that we support as well, which is why their logo is on there as well. But on the instructor station to the right, there's just three big whacking great buttons. And you can see we enter an airport, and then it shows us the runways, and we click load, and it gives us the runways at airport. So we put EGLL, which is the code for London Heathrow. We use the ICAO codes because they're the ones that pilots know, and as I say, it's pilots operating this. Push that big button and it's takeoff. That one puts you at 4 mile finals. That one puts you 8 mile finals. You can pause and unpause the sim, and then you got load and save and snapshot. So if you're a fun position, you want to save the snapshots, so you can get pictures afterwards because they're almost inverted. Trust me, it happens. People do that, and the pilots sit back and giggle. We can also see the plot of the ILS, change the weather, or shut down the system. It shuts down the whole system across, and then we've got diagnostics along the bottom as well. How do we build that? Well, FSUIPC, like I said, has this memory table, and this is the memory table that we have. So we look in closer here. You can see down the left-hand side is a memory offset, which is in hex. So you can see the hex values on the left. You can see the size of that the memory location. You can see what it does. So nav1 is our navigation system 1, and typically on most aircraft they have 2 and nav1 and nav2. We have a localizer and glide slope. Now, localizer is the center line. It's a signal out from the runway, and a glide slope is the same again, but it's the slope that we fly down as well. It then tells you what simulator system it works on, if it's been proven to work, etc. Over here, I've left the top of the table off. That's not important for us at the moment. This bit here is in the middle. So if we look that a little bit further, we can see that you've got the offsets, and this is the integer. So that's a 3,144th location in the memory table to grab that, but you get a hex offset because you don't know where the beginning of that memory block is. That's never shared with you. You just say, I want to go to that offset, and then FSUIPC takes control of the rest. You see here, though, that you got memory location of 1, so that's 1 byte wide. That's 1 byte wide. This is 2 bytes wide, that's 4 bytes wide. But you can see if you look at the table, so nav1 signal strength, was originally only going from 0 to 256. So they could have fit it in 1 byte, but obviously they knew they were going further. So later on, for VORs, which is what we use for navigating around the world, if GPS isn't available, that gives a signal strength from 0 to 1,000,000. So obviously they knew they needed that memory size when they designed this, even way back in like flights in 2000. As you can see there, it's quite actually. I had some red boxes to highlight that as well. So how do we do that though? How do we control that? Well, originally FSUIPC was you'd write it in C, or Luau was another one, which is like a scripting language, and Python. But I'm a .NET developer. So Paul Hennity, a .NET developer, has written this fantastic client DLL for working with FSUIPC, and it's written in .NET, which is awesome. So it's broken out most of the stuff. He's constantly working on it and beavering away. And you can download this from his website. As you can see there, the link on the bottom of the page. Before we go into it though, just in case you're not a C# .NET developer, or you've forgotten what they are because you use var all the time now and you really don't care what an int is and how big of a number it is, it's important to grasp it. So a signed byte is 8 bits, gives minus to plus 127, and a byte is 0 to 255 because it's unsigned. Unsigned byte, and then you got your shorts, your ints, your longs, and your chars, which is the odd one at the end as well. So you can see there the size of the values, and that becomes important when you're starting to look at what values you can and can't put into the memory locations. You can see the reference there to the docs.microsoft if you want to go and look at it a little bit later. So if we look at the memory locations again, so one of the things we want to do is control the pause, the sim, and we also want to control the gear going up and down. This is the emergency button that I said the instructor had to the side of the sim in case the gear lever breaks, which it does from time to time. The gear lever is an analog input, so 0 to 16383, and that's because the gear position lever could be a variable resistor, which can control where the handle position is as well, which is why it's got such a big value. So if we look in that inside Paul's DLL, you set the offset by giving it a name and the hex location. So you can see here that we need it to be 32-bit because it's 4 bytes, and the 16-bit because the pause is just 2 bytes, even though you only set it to 0 and 1. And then you can see the hex offsets to the right here. And then we're just setting that one to true because it knows that it's that offset. You can set a default value. So if we go across to Visual Studio, which actually isn't opened, let me open that. What I'll do while that's opening, and on the side, oh, it's not. It's gone all over the place. Demo gods have not got me. There we go. While that's opening, I'll carry on talking about the. Actually, no, it's going to open real quick for me, I think. I thought I'd opened it, but I hadn't. There you go. That's because we were talking COVID at the beginning of the talk, weren't we? There we go. So I'll bring this across. If we look at the top of the thing, and I should have had it on a white background, but I'll just zoom in for you. You have to accept the fact that I'm a dark mode fan. You can see here we've got the gear control and gear position, which is set at the top, and then I've just shown off one. The fact you can set airspeed as well. And then what we do is just have a timer that ticks every second and goes around and checks the process is loaded and then enables it all. And then when you remember that box where I told you put in the EGLL and click load. What that does is that reads in a database, which is literally a CSV file of the 28,000 runways and airports that are within Microsoft Flight Sim. It reads in a CSV file, which is provided by Microsoft. And you can then read that in, and then we take that, it's an array. So then we're just looking at array for EGLL and then pull in the airport. As long as the airport exists, we populate the checkbox, the drop-down list box. With the location or the runways that are available at that airport. Heathrow within Microsoft Flight Sim still has the 0523 runway, which doesn't actually exist in the real world anymore. That's where Terminal 2 is, but obviously the simulated world, they still have that. And then we have the buttons. So we've just got click handlers for buttons. And then we move the aircraft to approach. So if you click the 4 mile button, what it does is it sets the slope to 3 mile, but as a default, just in case the runway doesn't have a default slope, because it may not have an ILS. If you look at, say, runway 22 at New York, doesn't have an ILS, only has a VOR approach. Then we obviously just set it at 3 degrees, which is a standard one we fly. But if there is one there, we update it by reading in the one that's in the flight info. We set the heading to the runway heading. We set the threshold where the threshold is geolocation in the simulated world. We set the nautical miles and calculate heights. And we set some other bits. The fact we want it on the, we don't want it on the ground, want it in the air. The ILS heading, altitude, and the pitch and bank to make sure the aircraft is there. The pitch is 2.5 degrees. If you ever watch a jet aircraft flying, it always flies about 2.5 degrees nose up, even when it's descending down the glide slope. So all we do is we provide less power, so it just falls. We trade the power against gravity to make sure we come down at the correct body angle. You know, if you look at the orbiter when it used to fly in, that come in between 7 and 11 degrees, sometimes up to 15 degrees. Depending on how much they're trying to bleed the speed off. And then we just move the aircraft that position. So this connection and move aircraft is all within Paul's DLL that he provides as well. And then what we do is if the distance is less than or equal to 4 miles, because we call this function with maybe 8, and we did have a button for 12 as well, we set the gear down. So that is just setting the gear position, and we set the value to that value there, and it sets it down. And then we have a play, pause, and play as well, which goes on at the bottom. So as you can see, it's fairly simple. We've got ILS helpers as well for doing the ILS and weather, but it's just C# code. It's nothing spectacular and difficult, but you can write that to control your flight sim. And the good thing is, if you've got Flight Sim 2020, you can download FSUIPC for Flight Sim 2020, and you can take control and have complete control of your simulated world with all your IoT buttons and switches, and get your IoT geek on and work it out. But let's talk about, I've got some time left, I've got about 20 minutes left. So let's talk about what we do with the simulated world. So this here is a Cat 3 approach. This is a 737 flying approach. Hopefully you can hear the sounds. Someone stick their hand up if they can.
500.
Yep, I can see Pete doing that. You can see the call out there, 500 feet above the ground. It did about 160 miles an hour. 400 feet above the ground, so they can't see anything out the windows. That sound is the trim control, so it's autopilot back in the trim off. 300 feet above the ground, still nothing out the window, still a foggy day.
200.
Still nothing outside, about 150 miles an hour now.
Approaching minimums.
That's our decision point.
100.
100, just about see.
Minimums.
So now 50 feet.
30.
A light.
20. 10.
The aircraft derotates. It's landed. Autopilot being disconnected because the 737 doesn't have auto rollout like the 787 where it tracks the centre line. You can see it's put it slightly to the left of the centre line. The 787 has GPS augmented over the top as well, so it can update that to make sure it's on the centre line. And then what we do, we have to slow from 140 mile an hour our final approach speed when we touch down, and find those amber and green lights to get off the runway. You'd think we have to slow down 140 mile an hour to do that to get off the runway. And you imagine driving along the motorway at 140 mile an hour and trying to find a slip road in fog. That's what we have to do. And then what we do is we vacate until those lights turn solid green and there's no amber lights mixed in with them. And that means we're exited the runway, we clear the runway. We can clear it to the tower as well. At some airports, certainly US, you tell the tower you'll clear the runway. The UK, they see it on the ground movement radar, but they like us to back it up as well. But you've got another aircraft that's 2 minutes behind you at Heathrow. So you have to get off the runway pretty darn quick. So that's why we thunder along the runway, stamp on the brakes and get off as quick as we can. Even on a good day, on a normal clear day, they'll be 60 seconds behind you at London Heathrow. So if you ever land at Heathrow and you think, oh, they've been a bit abrupt on the brakes, it's because we're trying to get off as quickly as we can because the aircraft behind is quite tight. Oh, I shouldn't have done that. I wanted to go on to the next one. So let's talk about localizer and glide slope and why I'm talking about this. So if you go near any big airport, you'll see these antenna at the end of the runway. You'll see here the localizer antenna at the end of the runway here, and it looks like this. And then you'll see a glide slope, which is about 300 meters in from the end of the runway from the start point. So it'll be about here somewhere, typically on the left-hand side of the runway. You'll see this one here, which is a glide slope as well. And what they do is they put out two frequencies, 90 hertz, 150 hertz, on a different frequency band. So it's a pitch that's out on that frequency. So you have one frequency for your localizer, another frequency for glide slope, but they're dual channeled, and the nav boxes these days do it all for you. And then what it listens to, you get more than 90 hertz, you're left of the center line, you get more than 150, you're right of the center line, you get them both together, they mesh, and you get a single tone, and you're spot on the center line. Back in the day when this was all new technology, the pilots would listen to the tones in their headsets. I had a go at doing this during my initial pilot training, and it's hard work, just listening to these two tones and trying to mesh them so it sounds as one tone rather than two different beeps. It's hard work because you're trying to work out, is that the lower one or the higher one? Do I turn left or turn right? It's like an intense hearing test. But the instructor loved grilling us on it. They thought it was hilarious. But that's what we have. And like I said earlier, we have that signal into Flight Sim and FSU IPC. So like I say, we push that 4 mile button. What we want to happen is it position the aircraft out. And also on that ILS helper page, it pulls in the ILS lock and glide slopes. They're the memory locations and the bytes, and they're signed bytes. So minus 127, plus 127. So if you get all the way out to full fly, because on the aircraft there'll be a needle that goes all the way out to left and right. If you get all the way out to full fly left or full fly right, then it'd be minus 127 to plus 127. You're outside that, things are bad if you're left and right. You could hit a building potentially. So we get all sorts of bells and whistles and warnings. The glide slope is up and down. Obviously, if you're above the glide slope, it's not good because you're too high and you're going to maybe land long and go off the end of the runway. So if you're too long, you go around and try again. If you're too low, though, you get too low and the plane starts shouting at you, glide slope, and that's because you could be landing short of the runway, hitting a building that's underneath the approach. So there's lots of systems in there to remind you, and there's also obviously 2 pilots on board the aircraft. But what we're trying to do is track and draw. So we read that data in, and the other value we read in, which really actually I should put on this slide, is the DME, distant measuring equipment. Most airports, big airports, have DME, which is distance measuring equipment, which tells you how far you are from the end of the runway. So from this point here, at the end of the runway, the start point of the runway, the distance back from that, and we can take that distance. In our case here, we push the 4 mile button, it will say 4 miles. And then as we go down, and that value changes every 0.1 of a mile, we take a reading from localizer and glide slope. We store that in an array, and then at the end of the session, we can draw the pilot's attempt at flying the glide slope. We draw the red line is the ideal 3 degrees, and then they're the full fly up and down as well. So if they hit full fly down, the green line will just track along the bottom here. But obviously the pilot that's sitting next to them will be looking out the window and probably get a bit concerned at what they're seeing out the window as the building comes flying towards them. But when we go to schools and STEM events, the kids, first thing they want to do is crash the plane. So it just bounces anyway in the simulated world. But then we talk to them about what they're doing and make them appreciate what's going on in the simulated world and the 3D environment around them. But from that, we can produce a certificate, which then gets printed out. We give them the glide slope and the localizer, and then it also gives them a Top Gear S score out of 100, and we have a board outside with a Top Gear like sticky magnet thing, because the kids love that, writing their name on it and sticking it on the board. We did go to an electronic one a while ago, but I prefer the magnetic board. And then they stick their name and move their friends up and down on the board as well. And it's a memento for them to take away, and it gives them a bit of kudos later in the classroom and the playground when they were the best. At corporate events, it's even better, because I've had a senior manager say that if anyone beats his score, he had a pilot's license. Anyone beats his score, they're sacks. And at the end of the day, he was about 7th or 8th on the scoreboard. So yeah, I'm not sure how that conversation went down with his team members later on. Where does the sim get around to? It gets around all over the place. I'm just looking at the time, we've got 15 minutes left. That was literally 1 year's worth of data. So in that year, it got to events all over the UK, Ireland, and across into Europe as well. And so you can see it gets around. It's literally a trailer. We've got Barry, our tame racing driver, who literally used to be a touring car driver, race driver. He tows it around for us. Wherever we need it to go, he's there and takes it. And if you've got an event, once COVID is over, obviously, that you'd like us to come along to, then let us know and we can come along. The charities we support, I mentioned Dream Flight, which is one of the big charities we support. We always go along to their day. But the other charities we support, we've got High Flight, which is the flight operations. And me being a pilot, I'm in flight operations. Dream Flight is more of a cabin crew and ground staff kind of charity within BA. But High Flight is one where we take disadvantaged and disabled kids and give them an opportunity to fly. So they go down to Kent Gliding Club and go up for glider lessons, or we arrange them to have a pilot go in and give them talks about the fact that you may be growing up in a horrible part of town, but actually you can do good. I grew up in East London. I've gone back to East London, the schools that I went to as a kid, schools in around inner London like Newham, and spoke to them and said, look, I grew up around here. I got into trouble when I was a kid, just like you might have done. But look at me now. I'm an airline pilot for a big commercial airline. Because I got the breaks, I got the arm around the shoulder and the help, and that's what we're there to do, is support these kids. Flying scholarship for disabled. The other money, every year we sponsor 2 people to go and get their PPL, private pilot's license, which is to fly a light aircraft. So we always pick 2 people that have got a background as to why they're disabled, and we sponsor them to get their private pilot's license as well. And that's all via Flying Scholarship for Disabled people there. And then once a year, we hand over the sim with a bunch of pilots to London Air Ambulance. They're a charity. If you don't know that, all the air ambulances in the UK are charities. We're fellow pilots and staff, and so we know them. And we hand over the sim to them and let them use it at their events. And they normally take it to 2 or 3 events a year to help them raise money. As well for their charity, which is fantastic, and there's no cost. We even cover the petrol for them, so that all the money they take, which is generally in cash, they just take away and take it into their charity as they see fit. And then if you do want to use it, shameless plug, if you want it, all we need is a 13 amp plug, which is there, or the C-form plug. And don't worry, we've got gender changes if you've got if you're coming across to Europe. And we need a space at 7 meters by 7 meters. The sim is only actually 2.5 meters by 7 meters, but we found that if you have a bit more space out the front, then you can have a bit of entertaining space for the people. And there's a big awning that comes out, stops people getting wet as it's raining. It fits for a set of standard double doors that's in most buildings. So we've even taken it inside exhibition halls and hotels. Quite often we do that. And then the van, Barry, arrives, puts it in place, and wanders off the van and comes back later to pick it up. All the pilots are British Airways line pilots, all on days off. They'll volunteer because all the money that comes from it goes to charity. So yeah, if you do wish to use it, you can make a booking by dropping us an email there, or reaching out to me on Twitter. My Twitter handle has been on the side of all the slides except these 2, the important ones, but it's just at Clifford Agius. And then you can book the sim. You can see there we took it into the atrium area of a central London hotel. Barry's getting quite adept at parking this thing in some odd places, I tell you. And then all we suggest you do is grab the kids, go out into the garden, make airplane noises, put your arms out, and go around the garden and just practice being a pilot. So you're going to be an ace on the day. And just like the young lads you can see in the bottom image there, come and have a go in our simulator and have a go at flying the plane and see what score you can get. What we started doing, we obviously did last year, but we started in 2019, is the system stores the scores. And if you provide on the day an email address, a way of us contacting you in the little slips that we give you as a boarding pass, it's a fake pretend boarding pass. You provide us with an email address on the stub of that. If your score is the highest score of the year, we take you into our formation sims, the ones we use for training, the ones I have to go to, and every other pilot around the world goes into every 6 months to literally hand our license over and hopefully get it back 2 days later from the examining team, so we can keep our job basically. So imagine being tested every 6 months by the exam team, or doing a code review every 6 months. And if you fail your code review, your job is on the line. Imagine that. That's what we do every 6 months. And then we do the same with our medical. Once or twice a year, depending. Once you get above 50, it's twice a year, but below 50, it's once a year, unless you have a medical reason why they want to reduce that down to every few months, maybe. But yeah, that's my talk. I believe I've got 10 minutes left, and I've got a slide for questions, and there's my contact details on the side. So if you have any questions, please unmute yourself and jump in. I'm going to stop sharing this so we can all just chat quite happily. and hopefully should see you all. There you go. Yeah, if anyone's got any questions, it doesn't have to be about my talk, just be about aviation in general if you really wish. I'll be around on Slack for a wee while. If not, you can grab me on Spotify. Spotify? Why am I thinking Spotify? On Twitter, you can find me there, or LinkedIn. I'm going to go and work out why my light blew, which is over there. Don't know what happened there, but it blew halfway through my talk. Started flickering and then went. Yeah, it's been great. Hope you enjoyed NDC. It's awesome to see all these people at NDC and how they've managed to put it online. I think it's one of the better conferences online that I've been to this year, or in the last year, should I say.
Thank you very much. It was really interesting. Cheers.
Thanks a lot.